Welcome back. Today we're going to be talking about distance, change, and absolute value. Content objective is students will be able to solve word problems involving change in distance or temperature. A language objective is students will be able to discuss the differences between distance and change. Why am I learning this? Well, it's important for many real-world problems like finding the change in temperature. First, let's go over some vocabulary. Remember that absolute value is the distance a given number is from 0 on a number line. So note, even the distance, the absolute value of a negative number is positive. Why? Because there's no such thing as negative distance. So for example, the absolute value of 3 is 3. The absolute value of negative 4 is still only 4 because it is a distance. Notice from 0 to 4, negative 4 is 4 units apart. So here, the absolute value of 11 is 11. The absolute value of negative 8 is 8. The absolute value of negative 19 is 19. And of course, the absolute value of 0. How far is 0 from 0? So notice when we're simplifying expressions with absolute value, you basically treat the absolute value as if they were parentheses in a sense, because they are grouping symbols. So you had to simplify 23 minus 9 first, which was 14. 27 minus 14, which was 13, and then from there, take the absolute value of each number, and you can simplify it completely then. So here, if I ask, what is the distance between negative 2 and 7? Okay, what would you do? Well, first, let's think. How far is it from 0 to negative 2? It's about right here. So I would say that's 2 units. And then where is 7? Well, it's 7 away from 1 towards the right. So here it's 7 units. So to figure out the distance, I would have to combine the 2 units it took to get to negative 2 and the 7 units it took to get to 7. So the distance would be a total of 9. Now here, what is the distance between 7 and negative 2? Okay, well, let's see. Okay, from 0 to 7, it's right here. So that's 7 units to the right. And then how far is it from negative 2? Once again, it is 2 to the left. But notice the distance between them, no matter which order it was, is still going to be 9 because it took 2 units to get to negative 2, 7 units to get to 7. So the total distance would be 9. So the point is this: when we're trying to find the distance, does the order of the numbers matter? The question is, does the order matter? The answer is no. It's still going to be the same no matter which order the numbers are. Okay, so let's take a look at another one. So here, how far is it to get? Let's go to negative 5, which is starting from 0 all the way to negative 5, which is 5 units away. And then how far is it to negative 1? Well, it's this far right here, which is 1 unit. Now notice here, how far apart are these? Well, let's think. I wouldn't add these two numbers because they're not making the complete distance. In fact, this one takes away from it. Notice, in this case, I would do 5 minus 1, which would give us 4. So I would say the distance is 4. Now, let's go the opposite direction. Now, let's first ask the distance between negative 1, which is here, and then negative 5, which is here. So again, the distance here is 5, the distance here is 1, but how far are they up from each other? I would still say 4. Why? Because 5 minus 1, since this already takes part of it, I only want to know from here to here, it would be 4. Okay, so for number 1, it says, what is the distance between negative 4 and 5? So we're going to go ahead and use a more formal approach to this, especially when we get numbers that are a little bit larger. We're not going to want to always write on a number line, but let me first talk about, okay, we're starting from negative 4. So here it is at negative 4, and here it is to 5. So we have 4 units to the left, 5 units to the right. So altogether, how far are these 2 points? I would say 9. Okay, but how could we use absolute value to show distance? Well, first of all, remember, absolute value is by definition the distance from 0, what we could do is simply find the difference between the 2 points and then take the absolute value of it. So how would I write this? I write it as the absolute value of -4 minus 5. So just like in the previous background knowledge, what do we do first? We have to do what's inside the grouping sign, which in this case is absolute value. So I'm going to, since it's subtraction, I'm going to add the opposite. Here, -4 plus -5, that's going to give me the absolute value of -9. And what is the absolute value of -9? It is 9. Okay, or like we discussed in the previous example, does it really matter the order in which we write it for finding distance? The answer is no. So we could have also wrote 5 minus a -4. So here, 5 minus a -4. Since it's subtraction, I'm going to add. The opposite of -4 is +4, leaving me the absolute value of 9, which is still 9. Okay, so at this point, go ahead and pause the video and try number 2 by yourself. Okay, so for number 2, it says, what is the distance between -3 and -16? If you remember from the previous example, what you can quickly do to find the distance between two numbers is simply find the difference between the two. So here you can take the absolute value of -13 minus, so notice we're always taking difference, a -16. So here subtraction, I'm going to add the opposite, which would give me -3 plus 16. Let's rewrite it here real quick so you can see. I took the absolute value of that, but first I had to simplify -3 plus 16, which is 13. Once we have that, we can say the absolute value of 13 is 13. Now, could you have gone the other direction? Instead of saying -3 minus -16, could you have done the absolute value of -16 minus -3? The answer is yes, it would still give you the same answer. Since subtraction, we're going to add the opposite. And then there you would be left with the absolute value of a -13, which would then give you just 13. So once again, please remember when you're trying to find the distance between two numbers, when you're finding the difference between the two numbers, it doesn't matter the order. You'll still get the same answer. So here's a really important thing to remember. If P and Q are rational numbers on a number line, then the distance between P and Q is the absolute value of P minus Q. It does not matter which endpoint we call P or which endpoint we call Q. We can switch them around technically. Distance will always end up being positive, okay, no matter how you write it. And that's what the absolute value symbols are for, to make sure that our distance is positive. So for two rational numbers, P and Q, the distance between P and Q is the absolute value of P and Q. That's important to remember. That is technically the distance formula on a number line. So let's look at some word problems. For number 3, it says, the number line shows 4 elevations in Death Valley, California. Enter the difference in feet between the elevation of Zabriskie Point and Furnace Creek. Okay, so let's see. They want to know how far is it from Zabriskie Point and Furnace Creek. So they did give us extra information, but reading the instructions gives us a clear indication of what our focus should be on. Well, Zabriskie Point is 648 feet and Furnace Creek is 178. So what could we do to find the distance between these two different elevations? Well, I can simply take the absolute value of the difference between the two. I'm going to go ahead and use Zabriskie first since it's the first one that was mentioned, which is 648. We're going to go ahead and find the difference, so we're going to subtract Furnace Creek, which is a -178 feet. So to simplify this, we need to simplify what's inside the absolute value first. Since this is 648 minus a negative, since it's subtraction, we're going to add the opposite, so this becomes addition. The opposite of -178 becomes positive. So I'm going to simplify what's inside the parentheses. So 648 plus a positive 178 is going to give us the absolute value of, let me do some side work, 648 plus 178 is 16, 11, 12, 826. But what's the absolute value of a positive 826? It is just 826. But we need to remember, we need to answer the question. We shouldn't just give a number. It says, enter the distance in feet between the elevation at Zabriskie Point and Furnace Creek. The difference in elevation is, let's write it down, is 826 feet. A lot of students will do the math and give me a number, but often forget the unit. So it's important to remember it is in feet. Number 4, a hiker starts hiking at the beginning of a trail at a point which is 208 feet below sea level. He hikes to a location on the trail that is 584 feet above sea level and stops for lunch. What is the vertical distance between where it started and where he stopped for lunch? So using the formula we learned, we are going to be using the difference of the two different points, which in this case was 208 feet below sea level. That below sea level is very key, as well as 584 feet above sea level. And again, above sea level is going to be really important. Because it's below sea level, that is a negative 208 feet. And here, since it's above sea level, that's going to be a positive 584 feet. So here, to find the distance, we simply find the difference of the 2 points and take the absolute value of it. So I'm going to write it as the absolute value of a negative 208 minus 584. So here, since it is subtraction, I'm going to add the opposite. So here we're going to add the opposite of 584 is a negative 584. So here, all we're going to have to do is simplify what's inside the absolute value symbols. So here, there's definitely more negatives. So right away, I know my answer is going to be negative. How many negatives are there? How many negatives are there? Well, since they're both negative, I'm going to combine them, leaving me with, 584 with 208. It's going to give me 729. So I know there's 729 negatives and 0 positives. So how many more negatives are there than positives? I would say 792. So what is the absolute value of 792? It would just be 792. So what is the vertical distance between where he started to where he stopped for lunch? I would say the distance is 792 feet. Again, please don't forget your units. And this should be he, not is, just FYI. Okay, so just moving on. Number 5, the distance between a negative number and a positive number is 12. What are the numbers? Why don't you pause the video and try this one by yourself? Okay, so here, they definitely asked that they wanted a negative and a positive number. So what I could do is think of some numbers that I can think of that would give a distance of 12. So looking at a number line, maybe I want to start with 5. That's a positive number, so I need a number that's negative. So going in this direction, let's see if we can make this a distance of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would work. There's a distance of 12. It should be 5 and negative 7. Okay, well, is this the only answer? The answer is no. What if instead I tried starting with, let's see, a 1? That's also positive. Let's go to distance of 12. So 12 part would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would work as well. Let's use different colors here. So this one was 1, and this one was negative 11. Are there any other options? Let's see. What if I started with 15? Could I make it work? Let's see. If I start at 15, to make a distance of 12, we would have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is not a negative number. So would this work? The answer would be no. This wouldn't work because these are both positives and they specifically ask for a negative and a positive number. So let's think, how come 5 worked and negative 7 worked, but 15 didn't work? If you thought about it, hopefully you recognize that in order for it to be both negative and positives, the number must at least be less than 11. It couldn't be 12, because even if we tried 12, let's see, I can show you like this. If I, for example, started with 12, which is here, to make a distance of 12, I would have to go down 12 to try to reach the negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would only give me to a 0, which is not negative. So you could have chosen any number between a 12 that was positive, or you could have done reversed. You could have chose anything that was negative 12 or more. But there are multiple answers. Now, you may have come up with a different answer than someone next to you, but know again that there are multiple answers. So some that I came up with were 5 and negative 7, as well as 1 and negative 11. So here, how would this work? Well, in other words, you're basically trying to find a number that if you take the absolute value of it, would give you 12. So the absolute value with the number within this could have equaled a negative 12, because that would be 12, or it could be 12. So notice here, 5 minus negative 7. Let's do 5 minus negative 7. If you add the opposite, that would have given you 12. Here, 1 minus negative 11 would have given you 12 as well. Now, the only limiting part was they did ask for a negative and a positive number, so we couldn't have used 2 negative numbers, which would have given us this type right here. Okay, number 6, find the change in temperature if the temperature rises from negative 18 degrees Fahrenheit and 15 degrees Fahrenheit. So let's take a look at this one. So first, I would set it up as taking the absolute value of the two different numbers, negative 18 and minus 15. Since this is subtraction, we're going to change it to addition. So we're going to add the opposite, which now leaves us with negative 18 plus negative 15. So I'd ask myself, are there more negatives or are there more positives? Definitely more negatives. Let's see, let's go ahead and compare how many negatives and how many positives there are. That way we compare how many more of each. So here, how many negatives are there? Well, there's 18 here and 15 here, so altogether there are 33 negatives. How many positives are there? There's 0 positives. So how many more negatives are there than positives? I would say 33 negatives. So here, let's just finish this off. The absolute value of negative 33 is just 33. So I would say the temperature change is 33 degrees Fahrenheit. But to go a little further, what happened to the temperature? Did it go up? Did it go down? Well, let's think. It went from negative 18 degrees Fahrenheit to 15 degrees Fahrenheit. So I would go even further and say the temperature rose 33 degrees Fahrenheit. But let's think a little bit more about this. Would your answer be different if the temperature dropped from 15 degrees Fahrenheit to negative 18 degrees Fahrenheit? So what if these two numbers flopped? Well, while the distance between the numbers is going to be the same, the change in temperature is different, okay? So the change is negative 33 degrees Fahrenheit, which would mean the temperature dropped 33 degrees instead of it rose 33 degrees. So there is a difference because going from 15 to negative 18, it does drop. And from here going to negative 18 to 15, it did go up. It rose. So last example, go ahead and pause the video and try the last one by yourself. So for number 7, it says the temperature drops from 7 degrees Fahrenheit to negative 17 degrees Fahrenheit. But how much did the temperature decrease? The student came up with different answers. Monique said the answer is 24 degrees Fahrenheit. And Matt said the answer is 10 degrees Fahrenheit. Who is correct? Explain and support your written response with the use of a formula and a vertical number line diagram. Okay, so first, if we were trying to find the temperature change from 7 to negative 17, I would subtract 7 minus negative 17, which is going to be the absolute value of 24, because when you add the opposite, you're basically adding these two numbers together, 7 plus 17. Okay, so the change is negative 24. How did I come up with negative 24? Well, I can see from going from 7 to negative 17, it is definitely dropping. So that's why I came up with negative 24. After I found that the distance between the two numbers is 24. Again, because I can see here that it's negative, it went down. That's why I put negative. So the temperature decreased 24 degrees. So who was right? Monique was, because she did claim that the answer was 24 degrees. But what do you think Matt did? Why did he come up with 10? Well, it seems to me he simply found the difference of 17 and 7. Okay, because the absolute value of the difference between 7 and negative 17 would give you 10. So here it's important that you do pay close attention to the signs of the numbers. Now, if you don't believe me, let me give you a quick visual. Here is a distance from 7, which is the red dot. Here's a distance to negative 17, which is the blue dot. So here, the distance from 0 is 7. Here, the distance from 0 is 17. So how far are they? 24. So it's really important that you know this. Is distance always positive? Yes. There's no such thing as negative distance. Distance will always be positive. But is change always positive? No. Change could be either positive or negative. The change in temperature could go up or it could go down. If it went up, it's positive. If it went down, it would be negative. So it's important to understand the difference between the two. Distance will always be positive, but change could be described as being positive or negative. So that is actually going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.